All right, so I think we can get started. I'm seeing 1:30. Welcome, everyone. Hopefully you were here just early enough to hear the intro welcome music. This is the Understanding Schema.org session, and this is led by the Schema.org group, if that wasn't obvious. And so today I just wanted to just sort of run through a couple of, ESIP winter meeting. What do they have us do here? Welcome bullet points here. So the first one is orienting you on Zoom and KikoChat. I imagine if you're here, you're already well oriented with Zoom and KikoChat. In the agenda doc that you see in KikoChat, you'll see at the very top a place to just put your name and affiliation and relevant information there. So please do that so we can keep track of who's joined us. What else here? Invite others to take notes. Yeah, so in that Google Doc down below, you'll see a section that starts with notes and an outline of the agenda. So feel free to drop notes in there or everywhere or anywhere for that matter. Do your thing. I'm not picky. I don't know if ESIP is. Let's see. What else do I need to say? So we have a couple speakers today. They're going to be sharing some slides. So I will, for the most part, just hand off to those folks. So I'll stop sharing, then feel free to share your screen when the time comes. And fingers crossed that all works well, but just give me a holler if you're running into a jam. All right. And I had written down a goal for the session, for me anyway, and maybe others can chime in during the open discussion part, but that was really just to sort of build connections with the other clusters and working groups here at ESIP. So this Schema.org cluster has been around for a couple of years now, working on some guidelines to help data repositories primarily describe their data sets, and we'll talk a little bit about how we do that. But it's probably time for us to sort of branch out and see where some interesting connections might be had with other work that's being done in ESIP. And so that was primarily the section. And honestly, a lot of thanks goes out to Andrea Thomer and a bunch of others who said, hey, what is this Schema.org stuff and how can our groups benefit from it or not benefit from it? Who knows? So that's what we're going to find out today and discuss today. So thank you for being here. All right, so let me go into presentation mode here. Are y'all still seeing the screen?
Yeah.
Take that as a yes. Yeah. Okay, cool. All right, so we'll do a little brief introduction into what Schema.org is and how our group has been organizing around it. And then we'll just sort of jump into some short success stories from our group and maybe others at like 3 to 5 minutes each story. And then we're going to sort of flip the script and hear from folks that aren't necessarily a part of the Schema.org cluster and just sort of hear their community use cases. So what they're up to and points that they think might be relevant places where Schema.org could help them out. And then really just after that, we'll have open discussion and dialogue and just sort of see where it goes. And we've got a couple prompts in case we get the lunch tired feelings going. And then finally, we'll just sort of wrap up with an update on the ESIP assembly endorsement. And so that's an activity where our group has been putting forth this idea that the work that we've been doing might be interesting for ESIP to endorse. And so we can give you an update on that initiative. All right, so the ESIP Schema.org cluster really revolves around this. It's not necessarily a technology, but a vocabulary, if you will, that has come out of the web publishing world, primarily led by the big search engines, Google, Bing, Yandex, Yahoo, all those, where they're trying to use metadata embedded in web pages as a way to sort of help search engines and other aggregators on the web understand what content on a web page is about. And so the ESIP Schema.org cluster sort of marries that focus from the web publishing world with all the great sort of metadata work that happens in describing scientific data sets. So, the content that we put in our DOI records, our, ISO metadata or whatever standard you're particularly using for your domain. This work or this cluster is really just sort of focusing on how do we marry these two so that all that rich content in your metadata records, can be embedded in these web pages for broader discovery and better reuse and all those things. And so just quickly on that point, so we're talking about embedding metadata in web pages. And I think what's compelling about that is that, we're mostly talking about data repositories here. Almost all data repositories probably have a website, and those websites probably have pages that describe data sets. And so as we want to describe or share information with others, in the past, we've used other capabilities and technologies to do that. And that's great. That's all cool. But what's nice is that we can sort of leverage this, this technology and technique that we're already using is probably sort of like the lowest common denominator, and use that mechanism as a way to disseminate that information, but also harvest it too. So we're not also just focusing on publishing this content, but how this content could be harvested. And so in our success stories, you'll hear both sides of that paradigm. And so this cluster is really focused on putting together a set of guidelines that will help data repositories and others describe these data sets on the web using the schema.org vocabulary. And the reason for that is just having shared conceptualization so that when content is federated or aggregated rather, that can be done reliably and consistency. And so you'll hear some of those stories in a minute. And because there's hopefully reliable, consistent federation across the folks that adopt these guidelines, you can do really cool things like automate validation and sort of harvest this stuff with sort of better confidence that what you're producing out as an aggregated corpus can be better searched by the end users. And folks from the group, please just chime in if I misspeak or have something that you feel like I missed or want to say. Okay, so the cluster, we meet sort of 2 times a month, bi-monthly, and we sort of monitor the schema.org initiative that's happening primarily out of Google. They put out these monthly updates. And so we watch those for things that we need to incorporate into our guidelines or things that might impact what we recommend to the data repository community. And we also accept contributions and issues at a GitHub repository, which you'll see later. And then we also sort of maintain and publish updates to that guidelines. That's primarily our work, is like, hey, what's going on in schema.org in the broader web publishing community? How does that impact our guidelines? And how do we further progress and improve discovery for data sets using this paradigm? And I want to emphasize that this is really more about discovery than data use. And that's been a really interesting conversation in our group. So I'm saying that, maybe you all disagree, and maybe there's some work to be done there, but we can certainly talk about that in the open discussion. Okay, so these guidelines. So what's new and different about them? Schema.org puts out their own set of documentation on how to use that vocabulary in web pages. And all we're doing is sort of amplifying that and sort of honing in on a geoscience perspective on those vocabulary recommendations by schema.org. And so really just sort of go into more context as to, okay, this is how you could describe a data set, but what does this mean in the context of the geosciences? And so at our GitHub repository, you'll see a lot of code snippets and some diagrams. What you're seeing here on the code snippet is the metadata that you would put inside the HTML, whether it's embedded right in the code or linked as a header. That doesn't really matter, and don't want to get too technical, but what we're showing here is some JSON LD, they call it, which stands for JSON linked data, which is just a way of sort of describing these things with identifiers and more structure for the semantic web world, if you will. So there's a number of different aspects that you can describe using a data set, and this is just a quick snapshot from the table of contents on our data set guidelines page. So there's a bunch of aspects of a data set you can describe using this vocabulary. And of course, the vocabulary can be extended. And so that's work that you'll see from Nick Jarbo in a second, how that's able to come into play. And that's really interesting because it means, that we're not just sort of locked into just what schema.org provides us. It really opens up schema.org to be useful, or the technique rather, to be useful for other initiatives. So, the soils ontology or others. So we're really interested in hearing those community use cases. And then finally, just want to finish up with, okay, so you've put all this schema.org in your web pages to describe data sets. Well, what's the point? Well, right now, by just simply doing that task, you're eligible to be right in this Google dataset search. And so, if you've implemented this, Google will come and harvest you, and you can see your data set showing up in this portal page that Google puts just specifically for finding data, which is really cool. It's I think most folks that have implemented the guidelines have said it's pretty easy to implement, not like a huge ask of your technical people to get this up and running, and there's broad benefit right away through this Google dataset search. And there's other initiatives that are doing this. So in one of the talks, you'll hear more about that. All right, so let me turn it over to Nick from the Magic repository. So Nick, if you're all set to go, I can stop sharing and turn it over to you.
Okay, great. Here, let me grab this. There we go. Okay, thanks everyone for being here. I'm Nick Jarbo, and I'm part of the Magic data repository. We have paleomagnetic and rock magnetic data, and I'm going to talk about how we implemented schema.org on our data repository website, and how that worked for us. So, why did we want to add machine readable metadata to our dataset landing pages? There was two main reasons. We were interested in having a way that other groups could index or grab metadata for our contributions and include them in other projects, especially there's a few EarthCube projects like MacroStrat. And we also wanted to have our data indexable by Google Dataset Search and EarthCube's Geocodes. And so we thought we'd give it a shot. So why do we choose schema.org for describing our data sets? Well, Google Dataset Search only scans the schema.org. So that was a big motivator. Also, the EarthCube's P418 project that was creating an index over various EarthCube participants. We're going to be using that also. That's not Geocode, so we were involved with that. And the JSON LD format is pretty well known. Other groups will be able to deal with it pretty easily. We were involved in the ESIP's science-on-schema.org cluster pretty early on. I remember Adam running a session at AGU back the last time it was in San Francisco. And that was a good workshop. And the Science on Schema.org cluster is very inviting to new members. And we were able to help define terms that we needed that weren't included in the current schema.org. We needed a geological time scale. So we worked with people and added those into the temporal coverage terms. how hard is it to implement the schema.org JSON LD if you're trying to do it on your data repository? Well, we already had summarizing metadata for our website. So we could just take most of that data and just slap it into the schema.org JSON LD format and put that onto each of our data sets. You also have to set up a site index to point to all of your data sets for Google to scan it. Originally, before the Science on Schema.org cluster, there was just a Schema.org documentation. It was very hard to adapt to earth science data, and it was quite a bit confusing at first for us. But with all these workshops and the Science on Schema.org cluster, it's been great. Adam Shepard has kept us moving forward with new versions and adding more and more terms that people want to use. Now there's clear documentation on the GitHub, as Adam said. We already showed these where we've got a diagram and then code snippets. It's very nice to have, for me, examples work really well to try to implement things. Also, there's discussions in these like facts where things might be confusing. What should you put where, and so on. So the documentation is quite good now at this point. What do we gain by adding schema.org to our data headers? Well, we get exposure of our data repository via Google Dataset Search. Adam showed this also. The Google interface is pretty nice. It's got a map and it shows all the variables that are in the data set and the license and so on. So this is really nice. Then there's also the EarthCube geocodes, and we have our data been indexed by them. And that's it. Thank you all. And I don't know if we're going to have any questions or just move on to the next topic.
Great, thanks, Nick. Maybe what we can do is, if anyone has one quick question specific to Nick's, we can take that. Otherwise, we can just wait till the open discussion there. All right. Maybe we can move on to our next presenter, which is Chantel, in place of Melinda Minch, who will be talking about the Polder initiative, the Polder data discovery enhancement research. They're doing some really cool stuff. Chantel, can you hear us?
Yep. Okay, I am going to try and pull up my slides.
Awesome.
Wrong one. Okay, can you guys see it all fine?
Looks great.
Awesome, thank you. So yeah, like Adam said, my name is Chantel Berry. I'm with the World Data Systems International Technology Office. I'm going to try and do my best to do Melinda's presentation justice, and if anything comes up, hopefully she'll be able to answer your questions. So I'm presenting on behalf of the Polder working group. We kind of took a different approach than the previous presentation. Polder is the Polar Data Discovery Enhancement Research working group. They're working currently on a best practices and federated search. So the best practices, well, first I'll say the challenges that the Polder working group has seen is capacity issues, so funding, trained personnel, maintenance and uncertainty, lack of standardization between vocabularies, best practices, and locating Polar repositories in the first place. So many of the general domains host Polar data, but technically is not a Polar repository. So that's why schema.org really suited our community well. And then the ESIP SOSO group here really helped kind of set the scene for the development of the best practices in the federated search tooling. So I like to show it this way, where you kind of have schema.org as the kind of more generalized layer. So is the more subset of schema.org, and then Polder is kind of picking and choosing our own set of best practices to apply on the back end in a more of a lightweight approach from the base of the Science on Schema guidelines that Adam presented about. So the ones that we chose were more relevant to polar data and what our community felt was kind of more necessary for our own use cases. So things such as discovery, temporal coverage, spatial coverage, parameters, sitemap, and other things as such. The Polder best practices are currently almost completed. They're not quite done just yet. So the next stage will be our community repositories implementing the Polder best practices, which again is a subset of the SOSO guidelines, in order to be included into our federated search. So right now we have the pilot Polder federated search up and running. The full pilot project is going to be completed at the end of March. We hope to have things such as the basic text search, date search, spatial searches, and whatnot included in the Polder federated search as well. The link is up there on the slide. I will post it in the chat right after my presentation, just for anybody if you wanted to poke around, try and search in different terms. And if there's any bugs or anything like that, we're looking for feedback or even just user interface questions, comments, concerns. We're more than willing to continue the development. So right now we have about 10 repositories that have committed to being included in the federated search. This does include Australian Antarctic Data Center, CCADI and whatnot. Now, the unique part about our Polder federated search is that we're also harvesting from Data One. So Data One does harvest repositories that have implemented the SOSO guidelines in general. We're hoping to include their repositories that have already done the work with the SOSO guidelines, as well as include and meet our community repositories about halfway when they implement the Polder guidelines in order to be included into this one single search interface. So this diagram kind of outlines how those interactions work together. So using the Data One indexing, and then as well as harvesting through the Gleaner tooling in order to incorporate everything into the single search interface. Again, this is kind of another diagram. It's in the first versioning, so it might change a little bit, but it kind of shows the relationship between each individual repository and them implementing the either Polder or SOSO guidelines in order to be included in the federated search. But we're also going to be utilizing Data One's basis in order for the repositories that have already done the work to be included in the search as well. So as of right now, our community has 3 options in order to be included into our search. So the first option is if you're already being indexed by Data One, our web developer has set it up that we are able to kind of index Data One already and have you included in our search interface. Option 2 is following the SOSO guidelines. And then as soon as the Polder guidelines are finished, implementing those to mark up your existing metadata structure to be included in the federated search. And then our third option is Melinda will be working one-on-one with our repositories in the future to help implement the SOSO guidelines as SOSO or Polder guidelines, sorry. And as Adam said, that there have been community experiences that shouldn't be too hard work, but as the Polder community can attest to, capacity issues are high on the list of challenges. So hopefully Melinda will be able to help alleviate some of those problems. So the next steps of our federated search, we intend to dedicate resources to taking the federated search from pilot to full production. We want to establish some usage data analytics, so assisting more repositories with their schema.org markup to be included in the search. Continue to develop the UI for tuning, scoping, including traditional knowledge, label support, and search faceting. And then at the conclusion of the full production year, once a federated search is up and functional, the final homing site will be established. At this time, Data One is being more than kind to us and with helping us set up our pilot and allowing us some server space. So if anybody wants to get involved, there are the Polder to Global Interoperability Hackathons. They're hosted bi-monthly. The next one is February 7th, 3 to 6 p.m. Eastern Standard Time. I can drop the link for that in the chat as well. And then there's also an advisory team meeting for the pilot that will be held February, early March. We usually send those invites out via the Polder data mailing list and whatnot. So keep an eye out for those. And then if anybody has any comments, questions, concerns, please feel to reach out to me at my email or Melinda as well. Even if you're poking around on the pilot site and you notice any bugs, we're more than grateful for any responses or notifications regarding those too. So yeah, thank you. I guess we might do a quick question if there is any, and then roll to the next one. What do you think, Adam?
Yeah, if anyone's got a question for Chantel, that'd be great.
I think going back to the slide that showed the 26 of 32K is an interesting one for me.
Sorry, which slide?
Showing 26 of 32K results as reported by Rob Casey in the chat.
Oh. Rob Casey.
The reason I ask is the NASA CMR has, at a collection level, 50,000 collections completely. So I'm interested in what kind of search would reduce the result to only 32,000.
Oh, I can talk about that for. So I think that was slide 7 that you saw that on.
You're very quiet, Melinda.
Oh, sorry. Let me speak up a bit. Is that?
That's better? The one.
Yeah.
So I suppose my first question is: is this search a two-step kind of search where it's looking at collections and then drilling down into individual data files, or are we just doing a search of the data file stroke granular level?
Can you hear me a bit better now?
Absolutely, that's fantastic.
Okay, great. It helps if I have my headphones on the right way around, so the microphone is facing my mouth.
The microphone was pointing to the back of your head.
Yeah. Technical, very technical. So I can tell you a bit about how the search works. So the way that it's working right now is it searches data one's index and the index that we created. So the idea was that because data one is doing all of this work already to go out and index things and make them very nice for us, we figured why not just ask it what it has. And
so,
then,
yeah. So the work we've done on federated search was we've divided it into 2 searches, and that's to try and mitigate this problem of getting just like the yellow pages kind of result, where the tail of the data never gets looked at. And it also helps with your accuracy as well. So I'm wondering, I suppose I'd have to dig into what was it data one you mentioned?
Well, it's both data one and the repositories that we've indexed. So right now, what you're looking at is a simple full text search. And I can't quite see what the search term is in there. If it's very general, then yeah, you're going to get a lot of results. Sorry, what was that, Chantel?
Sorry, so yeah, it was ICE. So very general for the Polder community.
Yeah, and also there's a search tuning problem right there as well, because I believe that there's a lot of data from the NSIDC, which has ICE in the name of the repository.
Right, so what I think you are doing is actually searching at the file level as well. For example, if I put ICE into Earth Data Search, I get 8,000 hits. That's at the collection level. So that might help ease the problem that, sorry, I'm scrolling down, Rob mentioned. On that note, I have to get to another meeting. So I've just thrown my grenade into your talk. I
wouldn't call it a grenade so much as a good illustration of why search tuning is important. And And so
yeah,
that's
but in this case,
something we
I
need to
think
work on.
it's in this case, I think it's a look at the architecture of how you're doing it, rather than just tuning. But hopefully I'll come back after I've been in this meeting and we can talk about that more. Anyway, sorry to cut and run, but bye. Thanks.
Yeah, let's move on to the next talks. This is great. We can always revisit it at the open discussion. Thank you so much, Chantel and Melinda. I mean, what you guys are doing at Polder is so cool. So it's really great to see a little bit behind the scenes what you guys are up to. Thank you. Okay, next up we have Matt Jones and Steve Richards talking about harvester interoperability. Thanks.
Okay, can you see my screen, Adam?
Yes.
So I'm going to follow up a little bit on what Chantel and Melinda were talking about. So I'm talking about the Data One network, which is a network of 52 repositories that's been around for about a decade. We onboarded 3 new repositories this last year. One is the French Biodiversity, National Biodiversity Center. Another one's Polder Data Center, and then the HydroShare network in the US. That brings us to 52 nodes that are part of the network. Over time, you know, these every year we get 3 or 4 different repositories joining the network, and using schema.org, following the social guidelines, is a new mechanism for joining the network. The major thing that we do as we're onboarding new repositories is help work through interoperability challenges with both the technical implementation of protocols for how the federation works, as well as content issues on making sure that metadata and data set descriptions are sort of harmonized and interoperable across the network. So when we harvest different member repositories, we can do it using multiple different metadata dialects. Traditionally, we used standard dialects like ISO 19115 and EML and Darwin Core and other DDI, the Federal Geographic Data Committee standards. All those different metadata dialects were supported. And over the last couple of years, we've supported schema.org, and we have about 7 or 8 of the repositories use that as their mechanism. Schema.org is a lot simpler and more focused on data discovery than those other standards. They tend to overlap with the other standards, but contain a lot less detail. But it's still a very useful way to get collection level metadata records about the data sets in a collection. So they cover things like citations, space and temporal coverage, the authors, variables, provenance information. And so from that, we can build a shared catalog that people can search all of the different repositories. This is very much what Chantel was talking about for Polder, but it's not limited to just the polls in this case. It's a global catalog. When you're looking at the content that we're gaining from these different groups, we run into a number of different issues, and you know, the devil is in the details in terms of interoperability. And so I wanted to sort of point out a couple of things that we've seen as challenges when we're harvesting from these different groups. I've broken them up into a couple of different things here, and I can go into more detail, but you know, at a high level, we want to be able to harvest efficiently and be able to pull information from repositories on a regular basis, like at least daily. To do that, we need to make sure that we can understand when content has been changing. So doing things like making sure that modification dates and versioning are well represented in metadata is really important for harvesters to be able to efficiently keep up with the changes that are happening at a particular site. One of the biggest challenges we've had in bringing new nodes online is that they don't provide a sitemap that basically lists all of the dataset landing pages that are at their site. And that simple thing is a really big barrier to being able to efficiently harvest. There are also some compatibility issues around things like how you represent the context. So it's really important to pay attention to the details about exactly how you represent the metadata that's in your landing pages. Those 4 different contexts that I have listed there on the screen all have different implications as to which namespace you're really using when you are trying to apply the schema.org concepts. And so we've got some specific guidance in the schema.org dataset guidelines about how to represent context, and you should use it precisely. We also run into lots of problems with things like lists. So this is where, like, if somebody doesn't realize you can use the list operator for controlling the order of authors, they might forget to do that. and then their data set doesn't show up how they expect it to when they look at it in a harvester. And so we usually work through with folks how to make sure that those things are showing up and citations look the way people want. So with all of that, we basically create a unified kind of a global schema that harmonizes the metadata from these different dialects, including schema.org. So we have hundreds of search fields through an open search API that can be used for searching for the data sets that are parts of these collections that we harvest. As was just brought up in the last talk, we are talking about data set level discovery, not granular level discovery. Although there are some details about granules in the metadata, we're generally not searching within a data set or a data collection, as NASA likes to call it. So that's definitely a second stage search. One of the things I'd like to point out, though, is that it's really helpful if people take from their schema.org record, if they add the subject of field, that allows you to point at a more detailed metadata record that you might already have in your catalog. So if you have a detailed ISO record or detailed record in another dialect, then providing schema.org at the high level for some discovery level stuff is great. You can point at the more detailed, say, ISO or EML record, and then we're hoping to be able to utilize both of those types of information when we're harvesting. So we provide a web-based query builder that lets anybody create data portals that use all of this metadata for subsets of data and metadata that's of interest to them. And so I'll just leave you with an example of one of these that was created by the data manager at the Toolik Field Station. So she put together a portal that has all of the data set that's collected in the specific region of their field station, even though that spans about a dozen different repositories and different groups that are usually using that particular field location. So there's some real benefits of being able to create these federated harvest systems. So I'm going to turn it over to Steve to talk about another one of them, and we'll go from there.
All right, thanks, Matt. Let's see, you have to stop sharing.
Yeah, I'm working on finding my button.
Okay.
There. Here we go. Okay.
So I just have a couple quick slides here. Can you see my screen? Let's see. Go for it. Come on. There we go. So the Geocodes is the search engine that we've been developing through the EarthCube office, and mostly working on harvesting data coming from Council of Data Facility sources. But also we've been, the original Project 418 development of a lot of this schema.org harvesting was done under the auspices of the previous EarthCube office and is continued with the current EarthCube office. So currently the Geocode search has, there's 17 active harvest sources that are coming from Council of Data Facilities, various NSF facilities, including Magic and that Nick was talking about. All but one of these are using XML sitemaps. So part of getting incorporated in Geocodes has been working with the facilities to set up sitemaps. One outfit is using schema.org item list, which we had to do some custom modifications to handle. Matt mentioned the issue about how to find when you're harvesting for the updating, how to know when things have been updated. The sitemap allows you to include a last modified date, which really could streamline the harvest process because you could identify quickly things that had changed since the last harvest. But many of the sitemaps we're working with don't include a last modified date. And in a lot of cases, those don't get updated even if they're there. We're using the Gleaner stack. You saw that show up in the Polder talk. This was also developed largely by Doug Fills, who's here in the call, to do the harvesting. The process basically involves going through the sitemap, accessing the pages that have the URLs, pulling out the JSON LD scripts with the schema.org metadata in them. They get loaded into an object store, and then the object store is processed to generate triples that go into a triple store, and the Geocodes user interface is based on querying against the triple store. So just a brief overview of some of the challenges that we've had to, or we're still working on trying to sort out, is some repositories have multiple versions of the same data set, and it's not always easy or possible even to identify quickly what's the most current version of that data set in a systematic way. So there's some proposals in with the schema.org issue tracker about how we can try to identify a consistent way of tracking versioning if there are multiple versions in this for a data set. Dealing with distributions, one of the things we've been doing with Geocodes is trying to streamline the linkage between finding data and identifying applications that can work with that data, and ideally even being able to sort of activate the application on the web with the data. And so this requires machine actionable metadata, particularly in the distribution section, the part of the metadata that describes how to get the actual data. One of the challenges is that schema.org only has a content URL. And in a lot of cases, the distribution link is to a landing page. And there's can be difficult to tell, or not easy to identify when the content URL is going to get you a landing page as opposed to actually access the data. Conventions for describing service-based distributions. This is one of the ways that we would have to deal with the kind of granules that Doug was mentioning earlier, which are generally accessed through some kind of service like a OpenDAP server or something like that. And so systematic ways to describe how that can work such that you can have a design software clients to read the distribution metadata and connect people with the services more easily. There's also questions with the details of how to describe the distribution formats. So dealing with things like compressed files, different packaging formats. Is the download URL going to get you a package or a file? Is it going to be compressed? And then also describing or documenting what the actual data format is in detail. For instance, is it a National Buoy Data Center RDB file, which will have a particular set of fields in it? Or is it some other kind of CSV file? There's lots of different conventions about how these different formats get used. So just having a MIME type in general is insufficient. You need more specific information about exactly how the data are serialized that you're going to get. Some other challenges involve the inconsistent encoding of dataset publishers. So if you go to the geocodes.earthcube.org search and run some searches, and in a lot of cases you'll see there's no publisher listed, but there is a publisher. It's just that different people are encoding that information in different ways in the schema.org metadata. Another issue is identifying who's the contact for metadata. So if a user does a search and identifies some problem in a metadata record, it's nice to have some way to be able to feed that back to the metadata provider. And right now in schema.org, there isn't a clear way to provide information about that, who's the contact for the metadata. And another aspect is in terms of what profile does this metadata conform to. So again, in the Polder talk, we saw the idea that we have schema.org, we have the science on schema.org recommendations, and then we have particular communities that might be using the science on schema.org recommendations in a particular way. And from the point of view of a harvester, it can be really useful to know which particular set of conventions were used in the creation of a given metadata record. And so it would also be nice to have some way to express that in the metadata with something like a DCAT conforms to property. So those are some of the challenges we've been working on. And a lot of this involves, like everybody has talked about, I mean, it's an iterative process between the harvester and the metadata provider to try to get enough consistency and content in the metadata to be able to implement some of these user-friendly operations we'd like to have in the aggregator search interfaces. And I'll leave it with that. Back to you, Adam.
Great, thanks, Steve.
Any questions?
Yeah, one quick question for Steve. Otherwise, we can move on to the community use cases. All right. Pierre, are you all set to go?
Sharing screens. Can I share screens?
Not yet, I don't think.
Need permission from you?
Oh, maybe. How about now?
Yeah, got the dialogue. See that?
I saw it briefly.
Great. So yeah, so this this use case or community use case. Can you see it?
I see a black screen.
Here we go.
Ah, thank you.
See it now?
Yep.
We got a message that Zoom crashed, but apparently it didn't crash. So just tell me when you can't see it anymore. But okay, so this use case is coming out of UNESCO's Intergovernmental Oceanographic Commission, specifically the IODE of IOC, so the body that's in charge of data and information exchange. And it's summarizing a project that was funded by the Government of Flanders, Kingdom of Belgium, to create a hub, an ocean info hub for some of the UN ocean affiliated agencies and also other partners that are federating under the UN Decade of Ocean Science for Sustainable Development. So there's a lot of data initiatives, digital twinning, interoperability frameworks, modeling and forecasting that are coming together with this. It's a global platform, but as we all know, getting data across these is very, very tricky. And so IODE is trying to use a neutral, or trying to create a neutral space, an intergovernmental space, where we can start to facilitate data exchange at a very high level first, very, very rough, and then from that establish a culture through which we can then get into the details of what kind of primary data types should be exchanged during this this initiative. Again, that's a decadal process, and we'll be trying to keep that up. But yeah, schema.org is the way we've done. So background and brief, I think go through this quickly. Of course, we're all familiar with the case. We have lots of very powerful data initiatives out there and also small scale data initiatives, but often they're just not connected or they're connected bilaterally. And we need that digital glue. And you know, it's the same story as we've seen in other cases, which are likely more developed than we see here. So we need to think about how to address it. So we have to understand that, you know, we're not going to have one system to rule them all. And so this federated exchange approach is key to make that work. People should be able to spin up and spin down solutions very dynamically. And that's the sort of vision that we'd like to see coming out of what will be an ocean data and information system.
Yeah. Sorry to interrupt, but your slides are not advancing.
They're not advancing. Okay, they're advancing on my side, but not yours. Let's try again. You see that?
It's black. Background in brief, thank you.
Did it just advance now?
It did. Seems to have.
Do you see anything now or not?
The Otis mission?
Yeah, okay. So hopefully it works. So the idea then is to connect everybody in this digital ecosystem framework. So again, it should be robust. That means it should be simple. And there needs to be an architecture to stick things together. And indeed, we've chosen the schema.org approach because of the market share that's there. And also because there are existing adapters to things like DCAT and other systems. So the member states of the IOC have approved the progress and the plan of Otis and some of the early work, and the project has been operating since 2020. And we're continuing to do so and refining the concept, bringing on more contractors and developing more demonstrators of the system. Really importantly, like all of the nodes inside Otis have to run their internal operations as they please. It's very important. Indeed, we're dealing with national oceanographic data centers and other roles which have reporting obligations, but they should be able to then project out at least the metadata of what their holdings are so that they're aware of each other and we can accelerate bridges being built, sort of thing. So, you know, same model. The web is the hub now. It's not like developing one giant portal or one giant system. We'll use the hub and we'll use our linked open data concepts and things to continuously exchange metadata. The Ocean Info Hub is being built on top of that as a demonstrator of how it all works and how it all sort of sticks together. And that's built on a very similar architecture to the others that we've seen. In fact, so Doug Phillips is also our primary contractor there. So the Gleaner stack is involved in the background. We've gotten our regional and national partners to project out a little bit of JSON-LD, schema.org and JSON-LD, and harvest that all together into a graph, which now we're building the web interface for to kind of socialize this idea, across our partners. So that's connecting a bunch of UN systems, primarily from UNESCO, but not only, and also some of our partners, regional partners, such as the European data holdings, and also smaller scale initiatives, but also very important ones like marine training, so that we can connect capacity needs to capacity holders, and then try to sort of make the ocean data space a bit more equitable in that regard. So once we have that sort of graph in the background, gleaned up all together, where then our stages are to help people build their own nodes that are thematic or regional. So the Africa node, for example, the Africa portal, the Latin America portal, the Pacific portal, on the fly. And without worrying that you're going to lose the data, because everyone's participating, everyone is their own source. So very similar to that. So that's the web of it all. At the top, you'll see the UN systems up there, and then we're connecting a bunch of regional hubs, thematic hubs, and national hubs together. We've activated a bunch of them. Some of them are already connected into the graph. And so far, our regions are the Pacific Islands, Pacific Small Island Developing States, the Latin American Caribbean region, and the African hub. And we're connecting up some of their resources and data aggregators as a proof of concept to show that it works. So hopefully we can scale it up. This is how it essentially works. It's not that complicated. Very similar to what we've seen before. Harvesting is done in from European, African, and Pacific systems, as well as UN systems that are publishing a little bit of JSON-LD or something that can be massaged into it. At this stage, that's okay. We're going to try to, we have funding to help some of the lower capacity regions in particular implement or hire contractors to project JSON-LD independently. Again, we want them to be independent nodes, and then we can harvest that up through Otis, the Otis architecture, into the hub. So it's working. Again, it's working in the sense that we can search across the various systems that are out there, ocean best practices, aqueducts for documents, spatial data is being worked on right now with GeoJSON or well-known text embedded inside these specifications. And there's a bunch of documentation on the web that Doug has written. I'll drop links into the chat. And yeah, we're continuing to expand that out as we go. So we're really happy with it because in a relatively short amount of time, we've been able to connect multiple regions and multiple key stakeholders around the world to at least become aware of each other and start the next round of development to drill down, define what kind of conventions we're going to need to share the major types of oceanographic data to accomplish the goals of the UN decade, but also of IODE and IOC in general. So I'll stop there. It's a bit, but I'll drop some links in the chat for the documentation and some of the things that we're up to. Everything's open on GitHub, and we're looking forward to working with Soso and others to keep at it and keep this sort of stability, because I really see a future where we just click in to data ones harvesting, to polders harvesting, and we really bring all those communities together, at least at a high level, and hopefully much more.
Thank you, Pierre. All right, maybe we can have Lindsay go next, if you're ready, Lindsay.
Yep, I should be able to. Give me one
Great.
second to share the right screen. All right, can you all see my screen?
Yeah, looks great.
Okay, great. So I'm Lindsay Barbieri. I'm the Agriculture and Climate Information Fellow with ESIP. So one of my roles beyond looking at sort of agriculture and climate information is in thinking about the sort of cross-cluster collaboration. And so that's what I've been really focused on at ESIP, is thinking about ways to bring different clusters into dialogue together and thinking about sort of the collaboration that can happen. So from that perspective, one of the ESIP clusters that I've been working most closely with is the Soil Ontologies and Informatics cluster. And unfortunately, Kathy Todd Brown was not able to make it to the ESIP meeting to give a little update and sort of bring this forward herself. So Kathy is the cluster lead along with Brandon Whitehead. But I just wanted to, bring to the group a little quick note about what this cluster is doing and ways that there might be, some cross-cluster collaboration and sort of unlocking that potential dialogue. So really briefly, this is just the ESIP wiki page for their group. And the mission of this group is really to connect the soils research community, as you can read here, with data and informatics tools for better research. There's, the group is well aware, we're all probably aware there's a lot of numerous international efforts ongoing to harmonize soil data collection. And this ESIP cluster is really interested in sort of trying to support the efforts by streamlining the communication within the community and providing use cases for the standards and potential test bed for tools. So with this, I just wanted to draw quick attention to their upcoming, direction and work in the new year, so spring 2020. This cluster is really focusing on, here's their meeting notes, sort of landing page for the bulk of the work that they're hoping to do this coming year is really focusing on a series of presentations paired with recap on soil semantic resources or semantic resources in general that may be useful for soils data and soils data sharing. So this will then hopefully transition to a data hackathon annotation exercise as well. But just to give a little idea about what this will look like going forward within this cluster at ESIP, they're looking to hear from a wide variety of people, and you probably all are very familiar with many of them here. So this is the schedule, the topic, essentially going through and listening to and hearing from folks from ODM2, SOSA, ENVO, GLOSSIS, and even schema.org. Folks, Adam Shepard here, I think is going to be a presenter there. And so thinking about specifically sort of drilling down and asking, what is the semantic resource that's being discussed? Why was this resource created? And how could this resource be used in conjunction with soil data, and who supports and uses this resource? It's sort of the main focus. And in getting this sort of snapshot from each of these presentations, the cluster is really hoping to then provide that as sort of a informational sort of little half page or one pagers for each resource, and then thinking about sort of the gaps or how this might help facilitate better conversations within the soil research community. And I think with that, I'll stop there.
Great, thanks, Lindsay.
Yeah.
All right, and Andrew, if you're all set to go, and then right after Andrew, we can jump into discussion and dialogue.
All right, can you see my browser okay?
We do.
Okay, yeah, so I'm gonna click through a browser instead of making slides because that seemed easier. But hi everybody, so I'm here in kind of like two capacities. One is as I've been the co-chair of the community data cluster for about 2 years now. We just merged with the community resilience cluster, largely because of the huge overlap between both our membership and our interests. And also because we've been working on one particular project and that's coming to a close, and it seems like a good time to bring them together. But part of the reason I'm here is because I'm talking about basically like interdisciplinary discoverability and some avenues that I see as potential future research. So like I said, I've been the co-chair of the community data cluster. One of the big projects that the big project that we were working on is trying to get a better sense of where the water quality data is for Flint, Michigan. I won't go into all of this, but the long and short of it is this is where the water quality data is for Flint, Michigan, which is, for those of you that are maybe not in the US, it's a pretty notorious case of basically government negligence that led to poisoning of this entire community and their water supply. So as you can see here, this is a lovely arrangement of PDFs and Excel spreadsheets that are not well formatted and not consistently formatted, and actually really, really hard to find. And over the last couple of months, I've been working with a student here to try to evaluate the curation that's gone on into these data sets. And the long story short, they're terribly curated. There's very little provenance information here, and so on and so forth. So the reason I'm talking to the schema.org cluster about this is because this is like what Bar was talking about, potentially an opportunity for cross cluster collaboration going forward. For problems like this, there's a big need for data, not just from the earth sciences, for in this case, it would be around water quality, but they're also social science data. And part of what I'm interested in, and this is why I started coming to the occasional schema.org meeting, is because I'm interested in thinking about how you could bring together social science data with earth science data, or facilitate search across different disciplinary repositories. And schema.org seems like a pretty good way to do that potentially. The other capacity that I'm here is as a faculty affiliate at ICPSR. ICPSR is the Inter-University Consortium for Political and Social Research. It's a massive social science data repository, basically. And let me pull up my notes on it. And I just want to, like, I think a lot of folks in ESIP are not necessarily aware of this because it is so far out of the earth science universe. But ICPSR maintains a data archive of more than 250,000 files, hosting 21 specialized collections of data in education, aging, criminal justice, substance abuse, terrorism, and other fields. It's a federal repository for a lot of like social demographic data, census data, things like that. And it also has a really, really robust curation team. I wasn't able to find numbers on how many curators it has off the top of my head, but it's easily in the dozens of full-time working curators who are working to make this data available. So like the kinds of collections that ICPSR have are things like this is their landing page for them. And some of it's like themed around topics, so firearm safety among children and teens, but others are more broad, like demographic research and things like that. And ICPSR, this is terrible to look at, but ICPSR does indeed use schema.org terms on their landing page, which you can see in this like page source here, in their landing pages for each of their data sets, but they're not using like science on schema best practices. So I wanted to share this with folks because I think that there could be an opportunity for some interesting interdisciplinary collaboration. Over the next 5 years, I think, ICPSR is about to be, hopefully, fingers crossed, but we're getting a very, very large infrastructure grant from the NSF, which was previously had a terrible acronym and now has a slightly less bad acronym of the research data ecosystem. And we're working on supporting further discoverability of data and also like faster curation and archiving of data. So I don't know, I'm involved in this project, and I think within that there's some potential opportunity for collaboration with earth scientists and other repositories. So.
Great, thank you so much, Andrea. That's really interesting stuff. All right, so if we move into open discussion, if anyone has questions for Andrea or anyone else for that matter, now's the time.
Yeah, I don't know if you noticed that, and there's been a pretty extensive discussion going on in the chat as well.
Yeah, let's certainly elevate that stuff. Yeah. I mean, I'm curious from Andrew's perspective, and so if you have a question from the chat, please feel free to chime in and bring it to the broader group. But one question for Andrea I'd have is, do all you need from the schema.org is just the cluster is just to like help assist and make sure that stuff gets worked out, or Andrew, from your perspective, are there other ways that we can help you and your initiatives there with like the Flint, Michigan water data and ICPSR?
Yeah, I think that there's broader conversations to have. So with like the Flint, Michigan water data, there's so many existing problems with it that aside from right now, I think our focus is like sharing the critique of the current data curation and data management that's happening there. And the pandemic slows everything down, but hopefully we'll have something written up about that within the next month or so via a ESIP blog post. And because it's all that data belongs to the EPA, there's some weird rules around federal records that are governing where it goes and how it's marked up and how it's accessioned. But I think this like broader use case of like, how do you bring together earth science data with social science data, potentially in service of social justice? I think that's what I'm trying to get at a little bit here, is one that merits some further discussion. And I think like part of the discussion would be like, is the science on, this is also me, I'm still pretty naive about what the science on schema recommendations are versus just regular schema.org. I'm not as familiar with that. But maybe thinking about that as a use case and seeing if there's anything, you know, making sure that that's facilitating that use case as well. And I say this also recognizing that, like, I know that there's also a layer of like like somebody building a search engine or something like that, or a harvester with this aim. But I think, I don't know, those are my thoughts on this.
So, Andrea, I'll say I agree with you about the cross-disciplinary stuff. You know, we at the Arctic Data Center, where we operate a repository, we're also having that problem where we have many different disciplines represented. And so although it might feel like an earth science centric view of the world, in reality, we're dealing with economics data and cultural anthropology and archaeology and many other types of data sources. So both at the Arctic Data Center and at Data One, we have members that are, you know, not environmental science groups, like so TDAR, the digital archaeology repository, and others. We've talked with ICPSR many times about the overlap. They use a different metadata dialect. So DDI is their primary, you know, approach to representing data sets, and it's a slightly different view of the world, but there are many in this kind of qualitative space that I think we should try to federate better with. They tend to be not quite as overlapping communities of practices with us, so it's a little more distant to pull them in. But Dataverse and the qualitative data repository and all these others, it feels like we should all be part of the same network.
Go ahead, Pierre. Yeah, jump right in.
Yeah, so yeah, I would strongly second that. I mean, we see the same thing in the UNESCO and UN data system. Of course, there's many layers to this. We are oceanographically focused, but again, this decade of ocean science for sustainable development will bring in a large degree of data sets from the social sciences, from economics. We already have a number of partners lined up in the decade programs, a network of ocean cities that are dealing with multiple layers of data. It's going to be tricky to sort of, as we all know, to kind of, you can't really do it top down in a way, but once people discover each other, and I think that's the strength of the schema.org layers, it's easy, people can throw in keywords. We need some multilingual support for sure in order to make it work across things, but once people find each other, then they can start having more productive conversations. Otherwise, you have typically the same high capacity nations and certain institutes within them working together, which is great, of course, but it won't lead to that inclusiveness that we need to actually address more global problems. So this is why I like it. You know, this is why we keep coming back to the sort of schema.org level, and SOSO is helping to stabilize that, and at least also within ESIP, creating a very collegiate space to discuss this and move it forward. That's not over formalized and can get things done. You know, people speak their minds here, and I think we have the potential. So yeah, for sure. I think I'd reiterate that point. If we can get things like Polder and Data One and the Otis thing just to nudge together more effectively and actually enable some cross-domain searches, that's where it's going to start. We don't have to agree on everything right off the bat, but at least we'll find things and then we'll say, well, we're so close here. Let's convene and get it done.
So Andrea, I have another question for you, which is more about the informatics and sort of ontology side of what you were talking about. So I guess this is relevant to the bar stuff as well. Like, are you also looking at a level of semantic compatibility among the data sources? It seemed like that was part of the challenge, and maybe that's the challenge for the soils group as well. And if so, like, we've been debating a little bit how far down that road to go with the schema.org stuff. Like right now, we've been talking about variable measured and how to just describe the measurements and observations and even qualitative stuff that's in data sets. And I think, you know, right now there's a proposal on the table for how to sort of go from very minimal to more detailed semantics in that space. And do you guys have thoughts on how far down that that path we should go, given that this is meant to be mainly a interoperable and lightweight discovery layer?
My main thought is that, yes, we should talk about that more, but I don't know what the answer is. Like for ICPSR, and so Sarah is a postdoc, Sarah Lafia, your ESIP fellow, is also a fellow at ICPSR. So please jump in if I'm getting any of this wrong, but ICPSR, like they do extensive curation at the variable level, and that metadata could theoretically be more, could be surfaced at that landing page level. But like, and that's something I was thinking throughout all of these presentations, which is like, and I saw a lot in the chat about that too, which is that it's so hard to balance that. Okay, what is the level for just baseline discovery? Like what amount of information do you need that versus how much should you be leaning on schema.org to facilitate actual interoperability? And I don't, and I think that's part of the question is like, how much do you need to know about the variables in order to facilitate search and then get to interoperability? Maybe that's the place to start thinking.
It can get really deep too. So yeah, we've been working on a little side project with ICPSR with George Alter, who used to be the director there, but is now emeritus. And we've been working on this thing called Structured Data Transformation Language, SDTL, which is a DDI effort to basically describe provenance relationships among derived data versions in their catalog. And we've been working on how to basically make that compatible with other provenance representations in Data One and Wholetail and other projects. So it's, you know, I think you can dive really deeply into this stuff with different groups, and each group tends to have a fairly stovepiped approach to, you know, representation that works really well for their community. And I think it is an open question how much of that we want to bring up to this top level, because it's a lot of work to do it, to dive deeply into those systems. And I think the federal agency systems are similar. They each have their own cultures and infrastructures that they've built around for decades. And so you can do really deep dives into each of these systems, and how much can we really gain from those, you know, pulling that up to the schema.org level. I think it's an open question.
I guess I'll jump in here that I think this goes to the issue of profiles, and it seems like each of these communities, you know, going to have slightly different ways of doing things, using different vocabularies. One of the things in looking at the variable measured question, I mean, there's some obvious hooks there where what, you know, the logical thing to do would be to just plug in DDI properties when they get their RDF vocabulary put together. Or likewise, you know, the linking out to different metadata records. What are the vocabularies that are used to describe file formats and service types and things like that? And you know, how deep do you go? So each one of these things could be thought of as a profile question. And so having a framework where we can define profiles, Doug Phils and I were talking about this a couple of weeks ago, you know, that if, you know, we want to have some kind of scheme where things are modularized, and ideally you could, following the pattern that's currently being used in the Open Geospatial Consortium and ISO, this idea of conformance classes, where you have a set of, you know, here's a set of requirements for things you might want to do, and here's a set of tests to determine if you meet that. So the validation question is really important. That came up in the chat, and we've been working on some shackle rules to try to do validation. And the nice thing about that is you can modularize a lot of that validation. So this idea of being able to define, well, here's a conformance class. These are the tests you run to determine if something's valid under that conformance class. Then you can do, you know, certain things to work with it. And it's kind of a truth in advertising thing. So what you need to be able to do then is in the metadata record say, you know, this metadata conforms to this profile. And that way a harvester or somebody who's trying to implement some software or something will know, okay, this is the kind of information that I can expect to find in this record. These are the vocabularies that I will expect to see. And it can allow you to implement some of these things and account for all these different ways people need to do things in detail.
Sarah, I noticed your comment in the chat about ICPSR and geospatial coverage. I thought they did have some of that in there. I guess maybe it isn't in DDI.
Not in DDI, yeah, and I think there's just a bunch more that could be done because we use place names quite a bit, but I think that, you know, beyond the bounding box, like there could be more to expose. Like since we have our variables indexed, for example, I think that could be kind of a cool like use case just to see how much more could be marked up beyond just the you know, place names like San Francisco or what have you. So
yeah, it would be really nice to have good vocabularies and place names that link out to, you know, better geospatial footprints. We've struggled with that, trying to find consistent sources of it. Recently, Christoph Genovitz and his team built something, a linked data representation of the Geographic Names Information System, GNIS, that's maintained by the USGS. And that gazetteer is now online, but the footprints are so crude. Like they oftentimes are at best a centroid. And so it's really hard to figure out how you go from place names to more, you know, geospatially explicit search, given the sort of place name vocabularies that are out there. So I wonder if that's like part of the linking process, is trying to get people to use more explicit geocoordinates in just their schema.org instead of only relying on the place name.
I see John Ralph has his hand up.
Hey, Adam. Yeah, I was thinking about what Steve said about using, you know, conforms to establish expectations for clients. And so is one of your goals perhaps, Steve, to have really good guidance, to have this group perhaps have guidance for that, such that you can then link out using what Matt said about you know, pointing to other dialects of metadata for service access, et cetera, machine to machine documentation?
Well, I don't think ESIP is in a position to sort of set rules for all these different communities, but setting up a framework for defining those kind of profiles, and maybe, you know, things like registries of shackle rules for defining different conformance classes might be something that's within reach.
Yeah, that makes sense, Steve. I was just having a framework is maybe what I was really getting at, is if there was a well-known, well-documented path from a schema.org to a service description, and there was a good way to, a well-known way to do that, then that might be enough.
Right, exactly.
Isn't that the realm of things like potential actions? A subject dear to my heart.
That's where a lot of those kind of service distributions, I mean, that's the current way that it's being implemented. At least that's what we're doing with the Geocodes stuff. I think there's discussion of that in the Science on Schema.org issue tracker, as well as long discussions in the Schema.org tracker about that. But there hasn't been much convergence in, or any kind of adopted conventions as far as I can tell.
Yeah, we're kind of on the bleeding edge of that with NASA CMR and trying to use those potential actions to guide things like Google Dataset Search to Earth Data Search with context intact, what we're calling smart handoffs, worldview to Earth Data Search. And most of it seems to be there. There are a few places where more work needs to be done, and I'm hoping to use this vehicle to try and promote those through schema.org, which is my main interest for being there. But we have some of that stuff out in the wild with NASA CMR. Yeah.
Right. So using something like a URL template to do that smart handoff through the
right. So if you look
point.
at any of so if you look at any of our CMR landing pages, there's a potential action in there that takes you to Earth Data Search for that specific collection. But it also describes the various parameters that Earth Data Search will accept. So if you went to schema.org, if you went to Google Dataset Search, for example, and you were interested in a particular data set, but you also said summer of 2006, there's enough information in that potential action template for Google Dataset Search to say, I can convert that into a temporal constraint that Earth Data Search understands. But the thing that's missing in schema.org is is defining what that parameter looks like a standard way of saying what a duration is and things like that. I've talked to Adam about this at length, is the polite way of putting it.
Yes.
But that is my holy grail from a discovery perspective, to go from something like Google Dataset Search to Earth Data Search with all the things you were searching in Google Dataset Search manifested in Earth Data Search, like narrowing down the specialization of your search engine, or indeed any service that you have. And I'd also like to see Google Dataset Search at the other end be one of the recommended links that are put into Google search when you say search for Modis. Like if you put into Google software engineering jobs in Washington, D.C., one of the first links that will throw up is a link to Google job search. We should have the same thing for Google Dataset Search. If you put Modis into Google search, it's like, I think you need this more specific search engine. We don't have that yet. I think Natasha Noy has said that's on their roadmap, but it's been a long time. The ability to just like keep going through that stack without having to reconstruct anything manually would be amazing, I think.
Yes.
To get right through from Google to Google Dataset Search to something like Earth Data Search, and then have Earth Data Search, once you've figured out what you want, hand you off to some visualization thing like Giovanni. It'll be amazing.
So our superstar in the chat, Rebecca, has her hand up, so we'll let her chime in here.
Adam, you're too kind. Okay, so I'm coming from the perspective of space weather. Now, to be frank, I am new to space weather within about the past year and a half or so. I come from different fields. But the problem that I'm seeing in space weather that's related to this conversation is that there is a effort across the major archives and repositories to unite under this one repository. But the problem that keeps increasing is that the metadata they want to use to unite these things simply becomes more and more complex. So there's, for example, the paper they're writing right now on this new metadata is over 30 pages long, and it doesn't even go into the details. So it's hard to understand. And so what I'm wondering is, what is the panel's perspective on this from experience on what's the better approach, right? Is it better to try to unite the different domains of space weather under one metadata language and then interface with something like Data One or and such using schema.org, or to let them do their own thing and then build something like Data One on top of that?
So Rebecca, I think that's a really good point, and there's probably not one answer to that question. You can probably pursue, different people will pursue different levels. Like standardization obviously helps. It narrows down the breadth of issues we have to deal with, and that's why we're doing something like SOSO and why standards like ISO 19115 exist. That said, I think we have to expect that over the decades that we've all been trying to be interoperable, those standards continue to evolve, new technologies come into play, people figure out better ways of doing things, and everybody's at a different place on the adoption curve on those different standards. So I think anytime we're trying to build a kind of cross-cutting infrastructure like Data One, it necessarily is going to have to deal with the messiness and sort of heterogeneity that's implicit in the broader community at any given point in time. I think pushing for standardization is good, but accepting that we have to deal with heterogeneity is part of the challenge. Like it'll never be a perfectly engineered top-down system that we can just say, everybody do it this way. So
at Magic, we might have a little perspective on this. We were a very small domain repository dealing with rock and paleomagnetic data. And we wanted to have a data model so that every data point is, in a table, so that you can do, very sophisticated searching and combine data sets. So we have, 4,000 data sets, and you can search, give us all the rows that are samples from this box, and it will across all the data sets. But that, is a very, it's very difficult to get large domains to conform to a data model, or you have to expand the data model, like you said, to, we had 600 or 700 columns. So I think it's really valuable if you have all of your data in a data model that can do sophisticated searching. But scientists always do something new. So they're going to always be expanding your data model. And it's a trade-off between combining large groups and having that interoperability, or having a small group that can do much more sophisticated and low-level combination of data. So it's a tough problem.
Since we also see that in our regional partners, in different areas, they're going to have very, very different capacities. And we can set conventions or standards or request them, but you can't do that and then sort of exclude a whole region from participating in open systems. So, very much with Matt and yourself there, Nick, on this, there has to be like a very low bar entry point where people can just intuitively describe things. It could be messy. Maybe it's even just extracted with some lightweight NLP text mining from descriptions, but it's quickly populated. It'll be messy, but it's your first pass, and it's already a valuable resource. It's like the raw materials, right, that you're going to need. And then you will have those high capacity communities, or communities that are just well aligned or working on a similar project, which you can even engineer over time, that will demonstrate the fully fledged functionality that takes the investment and sort of proves the point of why it's valuable, and hopefully generate some technology to make it easier for others to enter that space. So, arranging those actors and arranging that sort of successional pattern, if it's a digital ecosystem, we can use ecosystem analogies. It's like the successional patterns of ecosystems as they mature. You have your pioneer species, and then it moves on and matures into a settled status. I think you'll see something like that. I think we already do see something like that. And if we align a little bit to this and set our expectations accordingly and our entry points accordingly, I think then we'll have a lot more fun also, because we'll discover a lot more data.
Great. Anyone with one last comment? The time always flies by here quickly, but I want to reserve 1 minute just to give an update on that endorsement. But any final comments? All right, let's see here. Well, thank you all for your time. Really appreciate it. I just wanted to give a quick update on our roadmap to endorsement. So the next version of our guidelines is really close to being done. So we hope to have that wrapped up by the end of the month. You can view the link at the slides for the progress there, our GitHub project board. And then a draft proposal was getting worked on. Ruth Dewar just recently did a bunch of work in that. And you can see our roadmap for that as well. And then so we hope to submit this to ESIP in March. And then after that, there's a 30-day comment period and probably a couple more months before it gets finally accepted. So we're hoping to have a party at summer meeting. So we hope that we're all in person and we can toast our glasses to the Schema.org guidelines endorsement at the summer meeting. So thank you all so much for your time. We really appreciate it. For those of you that are interested in collaborating across ESIP, working groups, clusters. Thank you for your comments and ideas. We'll be reaching out, and please don't hesitate to reach out yourself. So thanks all. Have a great ESIP winter meeting. Looking forward to seeing y'all through the week.
All right. Thanks, Adam.
Thanks, Anna.
Right.
Last minute plug for the Assessing the State of Community Knowledge Graphs session on Thursday, if you're interested in graph-like data bits. So it's mostly going to be me and Doug, Phil's asking people what's going on with graphs in ESIP and thinking about new applications.
Great. Yes, please don't miss that. That sounds awesome.
I'm coming. I'm talking. I'm excited. What more could you want?
Sounds great. Bye, everyone.
All right. So long.